Right, so thanks for the introduction, and I apologize for the tedious technology delay here. Today I'm going to talk about a brand new vision that we have for multi-platform app development in Rust, tentatively named Robius. So in a nutshell, the goal of this vision is to create a cross-platform application development toolkit completely in Rust. The goal here is for developers to be able to leverage the robust, safe, and performant ecosystem that Rust offers without needing to delve into other languages, which typically complicates things. The second aspect of this is, as the previous speaker mentioned, the Rust experience on mobile feels a little bit neglected. So we'd like to elevate mobile to be a first-class concern among platforms in the Rust community. Before I go any further, I just wanted to give an overview of today's agenda. There's 3 exciting tracks in this meta group. The first one of which is Rust. This afternoon we'll have talks about how to speed up the Rust compiler, how to contribute to it, the next evolution of the macros project, and the path to a stable ABI. Tomorrow we have talks related to Rust in education and raising the impact that Rust can have in universities. And then tomorrow we have a selection of other talks about finding bugs and fuzzing, and then sparse indexing and cargo. For this vision, the talks that are most relevant are those related to mobile and web. I'll mention a lot of these as they pertain to our vision. For the rest of the day, we'll have a lot of exciting talks from the MakePad folks, both live application building and an in-depth overview of the architecture and the internals of how MakePad works. And then tomorrow we have another UI toolkit, Dioxys, which aims to allow you to write an application once but run it everywhere. And then Elong, the new async executive runtime from Huawei that was just mentioned. And then Osiris, which is part of this vision, which is a project focused on developing clean, fast OS interfaces in Rust for immersive application building. And then lastly, we'll have a deep dive into the Servo web engine and another UI project called Taffy, which is a revival of Flexbox. And then in the metaverse and gaming track, we have a lot of exciting talks, which I'm admittedly less familiar with, so I won't pretend to tell you what they are. But we have things dealing with extended reality, augmented reality, virtual reality, physics engines, game engines, and a lot of different graphics and rendering works. So a lot of cool stuff to look forward to. Choose your tracks wisely. Before I continue, one quick disclaimer. This project, this vision, Robius, is not formally affiliated with the Rust Foundation, though we do collaborate with those folks quite a lot. Neither the Rust project nor the Rust Foundation are officially on board. Okay, so let's dive in. What is the motivation behind this vision? I would categorize it into 3 broad topics. First is, I've seen a lot of application developers express the desire to use Rust for their applications. They just don't know where to start or how to get started. There seems to be a paralysis of choice among so many solutions which are in partial states of completion, and it's unclear how to integrate all of these disparate projects together into a single working solution that you can just grab and go and start working to develop an app on. Another thing that motivates us is that we believe there are some clear business advantages to be had here. If you have this multi-platform app development framework in Rust, you can deliver a consistent experience to your customers, and you can also provide your developers with a consistent experience, which helps you attract the best ones. It also helps you avoid redundant development effort, which saves you money and gets your app to market faster. And then, of course, as we all know, Rust is simply great. Right? But maybe not for cross-platform apps just yet. We have safety, performance, efficiency, and a lot of other benefits which everyone has already talked about. So I think ultimately our goal here is to attract front-end developers to the world of Rust, and as Josh was mentioning earlier, kind of spread this vision to the next 10 million developers. So expanding a little bit more on the first point, the state of the Rust app dev ecosystem is a little rough right now. There's a lot of competing crates, and competition is great, right? But many of the projects are incomplete, and that causes frustration for people. Newcomers coming into the ecosystem for the first time, unsure what to do. It's a little tough to discover these crates, generally non-standardized to do so, although we have crates.io as the registry. And then there's a lot of overlapping features across these crates, so it can be hard to differentiate between between each crate and which one will suit your use case best. And then once you've picked one, you're always unsure, was that the right choice? How do I integrate it with another crate? Perhaps I want to develop multiple different kinds of UIs, or I want to have an application that does many different complex things. To build on this, the documentation is relatively poor. I mean, this is not to hate on any particular project. It's a tough challenge there, getting good documentation and good tutorials, but we need someone to work on that in a dedicated manner. So if you don't believe me, all you have to do is search Google, or I guess here you can Baidu all of the different GUI forum posts, UI toolkits, and all these different things, and you'll see tons and tons and tons of posts about how many problems there are with all of these different GUI libraries, right? And this took me about 10 minutes to compile, so it's quite easy to find these posts. So I think you get it. So the second motivational point was we want to deliver a strong business case for REST application development. We can look at some existing applications that have already been developed in Rust and see what their pain points were, specifically as they relate to the underlying platforms that they had to support. So for example, the Signal messaging app. They have 3 separate repositories for each of these platforms, iOS using Swift, Android using Java and Kotlin, and then desktop using TypeScript and JavaScript atop Electron. And then the Rust layer is the underlying kind of business logic layer that talks to the backend Signal messaging service. So this seems like a pretty good architecture until you look at what is actually required to make this work. So there's very little overlap between these projects aside from that one Rust libsignal library. And in iOS, they have nearly 500,000 lines of code. In the Android app, they have 1/3 in a desktop, 250,000. So you're looking at 1.1 million lines of code just to deliver basically the same application on different platforms. That's quite a lot of work, and as you can imagine, it's incredibly challenging to do that consistently. I think actually, to Signal's credit, they've done a pretty good job of that with help from the open source community. But if you use Signal avidly, like I do, you'll start to notice some inconsistency in behavior across the different platform apps. There's another example, Element, which is similar. It's another chat client, a first-party application developed by the same folks who have developed the Matrix chat protocol. Not sure if you've heard of it, but it's a similar vein to something like Slack or Discord. They have a separate app and a separate SDK repositories for every platform, and this has led, unfortunately, to buggy and inconsistent UI and UX behavior, at least according to the reviews here for their iOS and Android apps. Right? It doesn't look so great. You can see they have around 6 repositories for all of these different things, some of which are semi-cross-platform, and I'll talk about that in a second. This semi-cross-platform effort they call Compound, and it came out of their own realization that what I've said earlier is basically the case. It's hard to design things in a cross-platform manner. Compound, I think I can best describe it as a design-only Flutter, a sort of design language that's shared across iOS, web, and Android. So with this, they were able to make some improvements to the story of maintaining all these different app repositories, but there's still some room for improvement. And then, of course, the third motivational point is that Rust is the right choice, we believe. As Josh already said in their talk, this is the most loved language 8 years in a row, and most recently, just for the first time this year, it became the most wanted, just barely edging out Python by 0.01%. So that's great, right? Whether or not this is true or relevant, I don't think it's particularly important, but what matters here is that there's this feeling that Rust is the path forward. We believe that Rust can be leveraged, we can leverage Rust-Great's feature set for a bunch of different parts of multi-platform application development. Obviously, the safety and the runtime efficiency, which I personally love coming from the OS world. We get easy and clear dependency management with Cargo, which is phenomenal. One thing I think that is understated a lot is the simplicity of cross-compilation and targeting other platforms. Rust does a great job of that, building on top of LLVM. And another thing that you may not have considered is that the Rust ecosystem is quite wide, and it covers a lot of different distinct domains, which if you compare it to some other cross-platform application development frameworks like Flutter or Swing or something like that, the same can't be said for those languages. Of course, Rust is great, but if it was perfect for UI development, we wouldn't be here. There are some shortcomings, right? A lot of UI folks tell me they're accustomed to inheritance patterns and other object-oriented programming design patterns, which is kind of difficult to realize. On top of that, it can be hard to realize that the commonly used pattern of shared mutable state. So what this means is a lot of times you'll see overusage of things like a reference counted pointer around a ref cell or the sync safe version of that rcmutex. And then there's also this pervasive mentality that compiler is slow, but I don't really find that to be the case, especially if you compare it to something like Android's Gradle, where you can spend 30 to 40 minutes waiting for a build to finish. We'll see if we can do better, but again, as Josh already mentioned, Nick will be giving a great talk on his series of posts about how to speed up the Rust compiler. So I think there's a hope ahead. Another thing, which Josh also mentioned already, is that there's a steep learning curve potentially, specifically for front-end devs. I wanted to highlight this because there was a survey from a Flutter consultancy called Very Good Ventures, where they found that their clients needed an average of 3.5 months to retrain their engineers to switch from something like React Native to Flutter. So it could be even harder to get them to switch from something like React Native to Rust. But the comforting thing here is that there's a pervasive theme throughout the community that switching to Rust will bring you huge gains, right? So I gave the example of the Element Matrix chat client before. They said that in their new Rust-based application, they can achieve performance up to 6,000 times faster. Now, there's a lot of things that were also re-architected, like the way that they talk to the backend messaging service. But the point is, whether or not that's entirely from Rust or partially from Rust, it speaks to the attitude that surrounds Rust, which I think is really powerful. So this also motivates their own cross-platform approach, which they call Element X. So this isn't basically I'm saying this is not the first time where we've seen this sort of theme come from the community. Okay, so now I'm going to talk about some of the goals of this vision. The top 3 goals we have are to create a community surrounding this vision of cross-platform application development in Rust and drive that ecosystem forward to a flourishing ecosystem. We want to create a complete reference design of the entire system stack, right, including the application and everything beneath it, and then develop at least one, but more likely a series of flagship applications as proof of concepts that developers can just grab and use off the shelf. As part of this, we aim to integrate these 3 and give feedback to Rust and the cargo teams, which in my experience they've been wonderfully receptive to when I've given them feedback about OS topics, so I'm sure this will be a fruitful collaboration. So to dive a little deeper, the community aspect of this, first up, we want to create a working group and track our status on something like an Are We App Yet website, pretty common in the community. We'd like to collect, identify, and kind of support a set of maintained, highly functional crates so we can have this nice, robust ecosystem across the whole stack. Personally, I want to drive a series of holistic documentation and really detailed tutorials that makes it easy for a new developer to come in and just get going real quick with their app. And then once we have this, we want to evangelize the power of Rust for something like application development, which is not a domain that is typically be considered one of its fortes. So for the reference design, I think it's actually quite straightforward. We just want to have a complete working example of everything beneath the application. I blurred it out here because we'll talk about it later, but the goal is just to support pretty much all the major platforms and operating system environments. And then for the third motivational aspect, the third goal, we want to create some proof of concept demos and a flagship app that shows off the ability of this framework. So one major enterprise-grade flagship app would be nice. That's what I'll get started on first. But the overarching goal here is to make it easy for new developers to grab one of these apps, fork it and modify it for their needs, and then be able to explore the well-commented, well-documented, and well-structured code for that application to help the learning process flow. I'm thinking that our first flagship app will be something like a Matrix chat client. I already mentioned Element, but there's another good example called Fluffy Chat, which is actually written using Flutter, which I think is debatably the state-of-the-art when it comes to cross-platform application development. In their case, they have very consistent behavior and a lot better user reviews than the first-party Element chat client. And I think a lot of that comes from the cross-platform ease of using Flutter. But it still requires some platform-specific code, so there's a little bit of room for improvement. And then once we have all this, I think a final goal is to advertise the business value of this vision, right? One of the value points here is that we can attract developers and customers with consistent UI and UX behavior. An enterprise who may want to use this framework ideally would not have to hire so many developers with deep expertise on particular platforms, but rather deep expertise on whatever application purpose they want to develop. Should be easier to maintain, and everybody likes rapid and consistent bug fixes. That makes for happy customers. Should be quite easy to smoothly integrate this with the rest of Rust's really robust ecosystem of crates. And the free and open source ecosystem in Rust is quite deep, especially beyond UI, and that's key. Also, this will have an open source, distributed, decentralized project structure, unlike something like Flutter, which is kind of wholly owned by Google. And of course, can't forget, you could use Rust. Okay, so what are the technical requirements of this vision? What do we actually have to achieve? So I thought of a few key requirements to split them broadly among things that need to occur at runtime and things that are relevant to build time, developer tooling, and things like that. And let's start with the first one, which is high performance. So when we have high performance, this is an obvious requirement, right? You don't want slow, buggy applications. What you get from that is a highly responsive application. So we usually refer to this as one that has low input to display latency, which is, as you probably know, an end-to-end measurement of latency from when a user first interacts with the device until when they see the result of that interaction displayed on screen. Another goal that comes from, another benefit that comes from efficiency is energy efficiency, which is particularly important on mobile devices, but also on other systems embedded and even just regular desktop computing. So how do we actually get here, right? To achieve this requirement, we'll use Rust. That gives us a lot of benefits right off the bat. There's no underlying runtime required. There's no requirement for a concurrent GC, and most of this stuff is handled at compile time, not just safety evaluation, but not just safety, but evaluation of consts, and then a variety of other things that you can do statically. Another thing that we want to make sure to do is avoid slow communication with the platform. The only reason I mention this is because there's quite a few projects that aim to bridge Rust to something like Flutter or another underlying UI framework, and they typically do a lot of serialization, for example, at JSON, and then use slow IPC primitives to communicate with the other process that's running the UI. I think we can do better. And then, of course, we want to allow developers to be able to easily profile the system. In a closely related domain, we want to have applications be able to start up nice and fast. So there's quite a few studies on the value of a low latency startup and giving low latency results to a user. So I'm sure everyone is familiar with Amazon studies about every 100 milliseconds of latency costs them 1% in sales, right? Or a Google study that says an extra half a second in search page generation drops traffic by 20%. So there's a lot of similar studies in the mobile domain, and the guidelines that typical mobile app publishers give, like iOS and Android, is somewhere between 1.5 to 2 seconds, maybe all the way up to 5 seconds for a complete cold start. So we would target something on the lower end of that. The good thing is that Rust does full ahead-of-time compilation, so we don't have the potential judder from running a JIT process at the start of the app. This gives us more consistent general performance, but potentially a lower theoretical max performance. But I think many cross-platform application frameworks would argue that consistency is most important. One potentially bad thing about Rust is that it typically results in large application binary sizes. Now, there's a lot of great tools to reduce that, but that is something that may be challenging for this requirement. As a side benefit, when you have very fast application startup, you reduce that iterative development cycle, which allows developers to be more productive. So it's a win-win for everybody. The third requirement that we want to hit is quick compilation, right? So this ties into the point on the last slide. Again, everybody has this pervasive attitude that Rust C is slow. Again, not sure that I buy that, but point taken. Some of the modern Rust UI toolkits, which you'll hear about later today and tomorrow in the mobile and web session, combat this by doing live reloading of their domain-specific language elements. And another way that we can combat this is to restructure the overall framework as a bunch of small crates, which can allow you to benefit from parallelizable compilation units. So at the very least, what we want is to achieve fast incremental compilation. Maybe it takes 5–10 minutes to build your application right off the bat, but then when you're just iterating, you can get a sub 30-second build or something. That would be nice. Fourth requirement I want to talk about is consistency. So specifically across how things behave on multiple platforms. The key principle here is that I don't think a developer should ever be required to touch platform-specific code, but if they want to, they should be able to with relative ease. And then a secondary aspect of this requirement is that the code that is abstracting the underlying platform doesn't impose too much overhead, right? So this is a big theme in Rust, the goal for zero-cost abstractions, right? So we want to get as close to the underlying native platform as we possibly can. Second to last requirement is the flexibility to incorporate arbitrary components. So what we want to do is allow the build system and the whole tooling infrastructure to support developers adding in their own custom dependencies into the framework and build, and then also in the future do something like be able to choose your own UI toolkit. For example, if you prefer Dioxis, you can use that. If you prefer MakePad, you can use that. Or if you prefer something else, perhaps we can look into supporting that as well. So I think this ties nicely into Josh's comment about the capability concept and bringing that into Rust. That will help facilitate this as well. And the final requirement is that we want to be fully compliant with platform policies. So it's often tempting in UI design to, or application development design, to do things that are faster than maybe the intended way that the application platform wants you to do, right? But we need to be able to take these applications and publish them to app stores such that we're adhering to all of these specific policies that every platform publisher has. So this means not doing things like accessing private APIs, or doing JIT illegally, or loading arbitrary executables in your application bundle. So basically, we want this to be usable for real-world publishable applications. Okay. Next up, I'll talk a little bit about what I intend our reference design to look like. So the system architecture will incorporate many components across this large open source ecosystem, many of which are already very featureful, and you'll hear about today and tomorrow, and on Tuesday as well. We have UI toolkits, even game engines, physics engines, abstractions of operating system services and platform interfaces, concurrency abstractions, and in the future, we can even explore other things for like remote off-device services, like Google services or other things that you would use from a mobile device. You may be wondering why I call this a reference design. The goal is for it to be a pre-integrated solution that will give you a application development experience known to work, right? But that doesn't mean it's the only solution, right? So these components, we want to make them loosely coupled such that they can be reused elsewhere, and that an advanced developer that perhaps knows better than someone just getting started can tailor this system stack to meet whatever complex needs they may have. So here's sort of a simple diagram of this reference design of the whole system stack. I think one of our guiding philosophies here is to just stay out of the way of the UI, right? So these UI experts know what they do best, they know how to handle that, so we'll let them be the active driver and the application logic be the active driver, whereas all of these other components, like our platform abstractions and the concurrent runtime, will act as sort of passive libraries that get driven by the application. As I mentioned, we want to be able to flexibly support multiple different UI toolkits. So you could layer in, for example, Dioxis above MakePad or instead of MakePad, as you saw in the previous slide. What this allows you to do is, as a developer, choose the UI model that you're most familiar with. So it helps you get a quick start, right? This is challenging. It's not an easy way. It's not an easy thing to compose arbitrary UI toolkits this way, but we have already begun talks in this manner. And I think, most importantly, this will help new developers make a gradual transition into Rust and Rust application development instead of just forcing them to go all in and abandon everything that they've ever known about front-end app development. We may even be able to layer in something like a game engine, such that the game engine drives the UI framework, so it can be used. It can, offload the difficult task of presenting in-game UIs to a UI toolkit that is designed for that purpose. And then it can incorporate other components, like these platform abstractions, to simplify functionality that isn't related to the actual gameplay itself, but is required for it. So if we were to expand this a little bit and see what the architecture of a flagship app would look like, for example, a matrix chat client, you see there's quite a lot of elements in the UI and the UX. I think I'm sort of low on time, so I won't go through all of them. But basically, the idea is that identifying all of this is the way that I will drive, the way that we will drive the development of the underlying layers, right? Everything beneath the application and the platform layers here, and it sort of uses that as a guiding force to determine what is priority and where we can make the most gains. Okay, so I'll wrap up since we're, everyone's waiting on lunch, so that's good. Finished early. So I'll leave you with a parting thought, right? So this is a brand new vision. We're just embarking on this journey. Over the last couple of months, we just began discussions. I hope to have a working group announcement coming soon, or some, news about this vision on all of the typical Rust channels that you frequent. And then maybe sometime mid-next year, have an initial pre-alpha reference design available so we can start using this to develop some applications. You'll get a lot more details in the upcoming talks this weekend and on Tuesday about multiple different UI toolkits, game engines, physics engines, concurrency runtimes, and platform abstractions. So you have that to look forward to. And with that, I'd like to thank everyone for listening and for coming. If you're interested, please come find me. We need collaborators for sure. We need contributors. You can find me at GitHub at Kevin A. Boos, or here's my email. So thanks very much. Appreciate it.